Hello students, let's begin lesson 5, linear approximation and marginal analysis. The theory of linear approximation depends heavily upon the tangent line. Actually, that's the starting point. Now, how did we study the tangent line? Here's a reminder. We begin with a graph of its function y equals to f of x and a given input value x equals to x0. And then from here, we have to find out the point and the slope, so that we can put everything into this slope-point equation of the line. How do we find out the point? Just straight up substitution. Just plug in x0 and run your computation. You get y0 value. That goes right here. And of course, this one we already know. Now we have to find out the slope. How do we get that? Calculate the derivative and then plug in the number. Not just the derivative function, because this is not a number. After calculating the derivative, you have to plug in to find out the slope. Once you do that, you're going to get the slope as a number, so that we get m value to put in right here. In the end, we end up with this formula here, but I don't know how useful that is to everybody. These 4-step process here, that's going to be more useful for most of the students. Let's see, we have a bunch of exercise problems here. Let me select one, maybe two problems. Let's see, how about this one? So x0 is 4. So y0 is going to be just straight up substitution. From here, plug in x equals to 4. And then we have square root of 4, which is 2. And 4 minus 2 is also 2. So there you go. Y0 value is 1. What does that mean? That means y equals to m times x minus x0 plus y0 is the slope point equation. And then it is saying that this is 4 and that's 1. Now, what is m? We have yet to figure it out. So let's find out. How do I do that? We must take the derivative and then plug in x equals to 4. Okay, let's take the derivative, and this is going to be an exercise for quotient rule. Denominator squared, and then in the numerator, we need u prime v minus u v prime, like this. That's the structure. U prime v minus u v prime. So what is u prime? The derivative of the numerator, and this is 1/2 power, so 1/2 x to the negative 1/2 power. And then v, no derivative computation, just straight up substitution. And then here, just substitution. And then derivative computation here. Derivative of denominator is just 1. 1 minus 0. And then here, plug in x equals to 4. So to this guy, plug in x equals to 4. And then run your calculator. It's going to be an easy job. Tedious, but easy. If you do that, you're going to get this value, negative 3/8. And then put everything together, we get the equation of the tangent line. And here's a visualization. Do you see the tangency at x equals to 4? Now, let's zoom in around x equals to 4. Maybe even more. Now, do you see that this tangent line and the original graph share a lot of ink around x equals to 4? That means this red line is a good approximation of this blue curve around x equals to 4. Of course, far away from x equals to 4, they're very different, but who cares? We want approximation around x equals to 4. around x equal to 4, I can think of many lines, but the tangent line is going to be the best linear approximation. The tangent line will share the most ink, basically. That's how the theory of tangent line and the theory of linear approximation are linked together. Let's see. One more problem. Okay, let's do one more problem. This one. Well, how about this one? Yeah, that looks a little bit more intimidating, so let's go ahead and do that. So what is y0? This is my function. And then here, I'm going to plug in x equals to -1/3. So this is natural log of 1 plus 2 times, typo, sorry about that. Exponential of, let's see, 3 times -1/3, so that's -1, and then plus 1 was there before. So this whole thing is natural log of 1 plus 2 e to the 0 power. Did I do this right? And e to the 0 power is, well, anything to the 0 power is 1, so this is actually 1. So it drops out, we get just 1 plus 2. This whole thing is log of 3. Alright, this is what we have so far. Y equals to m, x minus x0 plus y0. That's my slope point equation of the line. And then here, I have to do -1/3. And then this one is log of 3. And of course, nobody writes like this, double negative. So let's rewrite it like this. And that's the equation of the tangent line we are looking for. Y equals to m, x plus 1/3 plus log of 3. Of course, we're not completely done yet because we don't know the slope. Let's see, let's find out the slope. And for that purpose, we have to take the derivative and plug in x equal to -1/3. Let's take the derivative, and that looks a bit challenging because we have a composite function. Okay. What is the derivative of log of x? It's 1 over x, isn't it? But we have this composite function, so we're going to get 1 over whatever the inside. You see, nothing changes inside. That's the essence of the chain rule. I mean, it has 3 aspects. Outside first, which we just did. And then nothing changes inside. Inside stays the same. And then the third, we have to multiply the derivative of inside, like a dangling chain. And let's go ahead and do that. Let's put some space here. All right, let's take the derivative. Derivative of 1, that's 0, nothing there. And derivative of the exponential. Exponential always stays the same. Exponential always stays the same. And then, by chain rule, we have to multiply the derivative of the inside again. So that's 3. Remember this? Another chain rule because we have composite function inside the composite function. So the first chain rule here, and then when I calculate this derivative here, another chain rule here. If you simplify everything, you're going to get, let's see, 2 times 3, that's 6 exponential of 3x plus 1 divided by this one, 1 plus 2 exponential of 3x plus 1. A little bit bigger font will help. That's a derivative. Oh, what a challenge. Now let's plug in x equals to -1/3. And looks like that's going to make this thing very, very simple because we have e to the 3x plus 1 there. So I'm plugging -1/3 here, and then -1/3 there. And then 3 times negative 1/3 is negative 1. And then negative 1 plus 1. See, you get 6 e to the negative 1 plus 1 power, which is basically e to the 0 power. And in denominator, we have 1 plus 2 e to the, again, negative 1 plus 1 power. Because 3 times negative 1/3 will become negative 1, and plus 1 was there before. So we end up with 0 power again. And 0 power is always 1, so we get 6 over 1 plus 2. We get 2. So that's the slope. Plug in right here. Then we get the equation of the tangent line. The slope point equation of the tangent line. Let's open up the answer key here. Let's see if I did it right. Plug in, do your computation, good. And then the derivative computation. Don't forget this second chain rule. We get this after simplification. All right, plug in the numbers, we get 2. Consequently, we get this expression. If you break up, you get this slope-intercept equation, but who cares? Let's stick to slope point equation. And then here's a visualization. Again, around x equals to negative 1/3 here, the red line and blue curve share a lot of ink. This shows that the red line is the best approximation, best linear approximation of the blue curve here. You can consider other lines, but this line is going to be the best approximation. Tangent line is always the best approximation. Okay, so much for section 1, tangent line, and we're going to talk about section 2 in a separate video.